Okay, Anthony, I'm going to start it right now. Yeah, well, it's not going yet. So I'm going to start it right now. It's 1 minute before.
The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. This is Dave Krahl. I've still got about a minute or so before 10 o'clock, which is when we're scheduled to start, and folks are still arriving. So I'll give people a minute or so to arrive and get settled in, and then we'll get going. If you have a question, feel free to type it into the questions box, and we'll do our best to respond to you. I've got Anthony Estasi here helping me out, answering some of your questions. Take some of the workload off of me. So we'll get started in a minute here. Okay, let's get started. My name is Dave Krahl. I work here at Imagine That, and I do a variety of things here. I recognize many names on this list. Some of you I've talked on the phones to on the phone. A few of you I've even met in person, so it's nice to see you all here. This is I don't know how many master classes we've done before, about half a dozen or so. The concept is that we have someone that is a simulation expert who talks about something they're interested in. And we alternate between myself or other Imagine That employees and some of our customers who've talked about submission. So we've had some interesting sessions in the past, and they've been quite varied. And we plan to continue this every month on the second Thursday of the month. So this is the first master class of 2012. We've already got the next one scheduled with Scott Burry, who I see is here. Just a second, I'm having trouble with my questions. Sorry. Okay. So let's get started into the class. So I thought I'd start with a little history. For those of you who are my age, or perhaps a little older, or maybe just a little bit younger, in 1988, remember that Ronald Reagan was president. The Soviet Union still existed, and Rain Man was the top grossing film. Simulation models were procedural. They were programs like SLAM or Simon, ProModel, and GPSS. And these are where you wrote out simulation in a language, and everything was very procedural in terms of the way it worked. So you called essentially the software called a function to make something happen. That's the year that we released Extend, which of course is now ExtendSim, and that is we were the first message-based simulation environment. Today, most simulation programs are message-based, and these include programs like, of course, ExtendSim, AnyLogic, Simio, FlexSim. These are all message-based simulation environments. So I've got a quick poll for you. And you should be seeing this. And if anybody wants to answer that, what were you doing in 88? Were you building models? Were you not born yet? So I thought this would give us an idea of where everybody was at that time. Okay, nearly everyone has voted. I think we got one person left, but that's okay. Close the poll and share the results with everyone. So it looks like most, or about half the people weren't building any models at that point. We had some people using simulation tools. About 20% were building simulation tools, building simulation models using the existing tools. Okay. So what is a message? Well, a message is a notification sent to a block that something has happened. So they alert the block to a change in the application or simulation status. For example, all the blocks get a message when the simulation is open. Hold on a second, I'm getting the... There we go. I think we've got a little lag here because what I'm seeing you folks see is a little different. So there we go. Sorry about that. We've got a little lag in the presentation that's going on. So so one of the examples is a model. Every time a model is opened, each block in the model gets a message, and we do things like initialize things, set up maybe any initial conditions for that block. We might check to see if a database is available, if it's a block that requires a database, that sort of thing. Messages also occur every time a discrete event happens. So whenever the executive calculates that there's an event time, it sends a message to each block with that event time. The messages are sent when the simulation is complete, and this is used for removing or freeing up memory that's used during the simulation, calculating statistics that are calculated at the end of the simulation, and just general cleanup that the blocks would do at the end of the simulation. Another message is that the statistics are cleared. So each block that has statistics would receive this message and then clear its statistics. Another one is the block dialog is opened. And we often use this to set up the dialog so that based on whatever options you selected, certain things may be hidden or shown, or we move the dialog items around sometimes to make it easier to use. So these are just a small sample of each of 5 different kinds of messages. There are hundreds of messages, different kinds of messages in ExtendSim. Each one is in response to a particular system event. Most messages can be sent or received whether or not a simulation model is running. So this is interesting. So we could send a message to a block and it can respond to something even though the simulation isn't running. So ExtendSim is kind of live and running even when the simulation isn't running. So you can have the blocks do things outside of the simulation loop. And that's actually kind of unusual. Most simulation programs, you can only do things when the simulation is actually running. So I thought I'd start with a simple message. What we have here are message sequence. We have a bunch of queues and activities. So we've got a queue activity combination, which is fairly typical in a simulation model. We have our executive, which schedules and manages discrete events. We have a clear statistics block, and what this block is going to do is tell other blocks to clear their statistics, and a pulse block that sends out a periodic message. So the pulse block schedules an event in the executive every so many time units. Well, how does this all fit together from a messaging standpoint? Well, the executive calculates the event time for the pulse block, and that time arrives. So it's going to send a discrete event message to the pulse block. So we see that message going through the air from the executive to the pulse block. Then the pulse block says, well, okay, it's my event time. My job is to send out a pulse or send a message out my value out connector. So it sends a connector message to the clear input connector on the clear statistics block. The clear statistics block receives this message and says, well, my job was to broadcast the message to all the other blocks in the model that might want to have their statistics cleared. So it sends out clear statistics messages to all the blocks in the model with statistics. So why do we use messages? Well, for one thing, they're pretty easy to implement. If I want my block to react to something that happens in the simulation, I just put it in the message handler for that block. They're more object-oriented. So each block chooses how to react to a given message, and there's cleaner separation between the components. So in our previous example, we saw that clear statistics block really didn't need to know anything about the blocks that it was communicating with. And each block can decide how it's going to clear its own statistics. All we need to do in the clear statistics block is say, I'm going to broadcast this clear statistics message to all the other blocks in the model, and each one chooses how they're going to deal with that. So it's a very easy to use mechanism, and there's a nice separation between the blocks so that you could build your own block and have it clear statistics in a way that would be completely different from the way we clear statistics in our blocks. Blocks can be combined together in a wide variety of ways. So those of you that have used other simulation programs know that sometimes there's limitations on how you can combine blocks together that don't exist in ExtendSim. And a lot of this is because of our messaging architecture, that we can, the blocks actually communicate to each other through messages, so they can be put together more flexibly. I'll show an example of that just a little bit. Blocks also react immediately to a wide variety of system events. So, for example, if you change a value and some other block somewhere else in the model is waiting for that value to change, there's an immediate reaction to that. And that's important in simulation. It's possible. Another way to do this is to scan and keep watching for values to change. But if we don't get that message, we might actually miss a value change. So some value could change from 0 to 1 and back to 0. We might miss that change altogether. So by having a message there, we know exactly when that value changes, and we react immediately to that value change. So there's a variety of other message-based environments out there. Operating systems, for example, are one example of that. Something like Windows or the Macintosh operating system both use messages to communicate within the processes. Smalltalk, Visual Basic, and C++ class libraries are all examples of message-based environments. So this is a fairly common technique in modern programming. So I've broken it down into 5 types of messages in ExtendSim. The first is application messages. And these are messages sent by ExtendSim to a block. And this would be something like the open model message or the initSim message that's sent at the start of the simulation. Connector messages are sent over connection lines. Block-to-block messages are sent directly from one block to another, so they're very much like connector messages, except they don't have the connection line as a medium for the message. Database messages are sent by the database when either the content or the structure of the database changes. And there are dialog item messages, so that when you click on a dialog item, that sends a message to the block so that the block can react to that message. So when you click on a button, the block will do something. When you click on a parameter value, it can check the parameter for consistency, for example. So application messages are sent by the application in response to an application level event. For example, when the model opens, when the simulation initializes, or when a block dialog opens. So we do have some ways for you to get at these. There is a buttons block that allows you to call that code, that equation in the buttons block, in response to one of a number of system events. So here's a quick look at the buttons block. So if you wanted to have something happen in your model when the model is opened, you could check this checkbox right there, and that the equation in the buttons block would be called when the model is open. Other options include when the block is pasted, so you could put the buttons block inside of a hierarchical block, and when you copy and paste it, you could have that buttons block do something. It could add records to the database. It could look for other blocks in the model. There's a whole variety of things you can do there. Also, if a hierarchical block is opened or closed, or when the block is brought in from the library. So this is a way to manage hierarchical blocks by putting an equation in the buttons block. So I've got another quick poll for you.
Dave, can I interrupt for a second?
Sure.
It looks like a few people are having problems with GoToMeeting updating. I didn't know if you saw that.
No, I'm not watching those.
If you look at the questions towards the bottom of the list.
I'm not seeing any questions down there at the bottom of the list. I'm seeing other things, but not those questions.
Well, one is saying that there is no immediately. Oh no, hold on. The display is not updating. That's from Dan Houston. The WebEx does not seem to be updating. That's from Carl Norman. and Robert Smith
noticed
saying
a little bit of a lag earlier. Oh, okay, I've got a couple people saying that. Oh, I see it now. Okay. I'm not sure what we can do about that right now. Can you respond to them and see if it's working better?
Okay. Yeah. Sure.
Thanks. Or you can actually build your own block that responds to any of the system level messages. So let me throw in my poll here. Okay, I got some people saying it's okay. Yeah, I think we've got some lag problems here. So the question is, do you program an ExtendSim? Why don't you respond to that poll? It looks like we've still got a bit of a lag. I've got a preview here that doesn't seem to be working too well.
Robert Warren is saying that on his machine, the presentation is still showing the buttons block.
Yeah, that's what I'm seeing too.
And Carson is saying there's no poll visible.
Yeah. Some people are seeing it. Some people are seeing it because I'm getting some responses.
Okay, so I think people are just going to have to be patient.
Yeah, I don't know why we don't usually have this kind of issue with. There we go. That should be up for everyone. I've got most people voting. So we've just got some lag problems. I'm not sure why that is. That's unfortunate. Okay. Looks like we've got most people. So let's close the poll and share it. And we've got a good mix of people here. We've got some about over half have done some programming. People use the equation blocks. About 30% use the equation blocks. 7% no programming at all. So that's an interesting mix. It's always good for us to get an idea of that, because when we're working on features, we're trying to evaluate how much we weight programming versus non-programming. So let me hide that, and I'll wait a moment until it all comes back again. Okay. So the next kind of messages are connector messages, and there's a number of kinds of connectors, but there's three that we use for the most part, which are item, rate, and value connectors. Item connectors have a sequence of messages that propel items through the model, and we'll look at this in just a little bit how that works. I'm not going to go into a lot of details, but it's good to have a basic understanding of how items are moved through the model. There's actually a conversation that goes on between the blocks for these messages. The rate connectors move the flow through the model, or the rate through the model, and value messages broadcast a value change or request an up-to-date value from a connected block. So they work both ways. So if a value changes, a new value is broadcast out that value connector, or if a block has an input connector connected to a value connector, it will send a message backwards requesting an up-to-date value. So this is from Robin Clark's class, and it's a little hokey, but it works out quite well for explaining how the item messages work. So if we have one upstream block, say that's a queue connected to an activity, and the queue wants to send the item to the activity block. We liken this to a hot dog vendor. The hot dog vendor says, do you want a hot dog? So that's the queue saying to the activity, do you want an item? An activity, if it's not busy, would say, yes, I need an item. Then the hot dog vendor says, here's the hot dog, you need it. So the queue says you need to take the item. And the customer says, thank you, I've taken the hot dog. So this want, need, taken sequence is what moves an item through the model. And this is the push. This is the left to right view, or from the queue to the activity. There's also a pull from the activity back to the queue, and it works very similarly. Now, what would happen if the activity were busy? The activity would reject the item. So the queue would say, do you want the item? Then the activity would say, no, I'm busy, I'm shut down, whatever, I reject the item. So the hot dog vendor is saying, do you want a hot dog? You might say, no, I just ate, I reject the hot dog. So there's two responses possible for the wants message coming from the queue. One is a needs return, and the other one is a rejects return. So here's a quick animation. The wants message goes from the create to the queue in this case. The queue says, I'm not full, so I need an additional item. The queue says, here's the item, you need to take it. And the queue says, thank you, I've taken the item. So the ExtendSim blocks are very polite. Now here's a little more detailed look. This combines both the item messages and the value messages, so we can see how all this fits together. What we've got is a simple model with a create, a queue, a set value block, and an activity and an exit block. So we're creating an item, we're putting it into the queue to wait, we're setting a value on it, in this case is the current time that it starts service. Then there's an activity that's going to delay the item for some amount of time, which is a function of, we're adding together two random number blocks, and then when the activity is done with the activity, it's, when the item is done with the activity, it's leaving. So we'll see the first thing that happens, an item gets created, we send a message to a wants message to the queue. The queue returns a need saying, yes, I need to take an item. Then the create sends the needs message, you need to take the item. And then there's a taken message back saying the item has moved. And we'll actually see an animation here of the item moving to the queue. So that sequence of messages goes on every time an item moves. Now what's the queue going to do? Well, its job is to try to push items back out again. So it's sending the wants message to the set value block, the set block. And the set block is a kind of block we call a passing block. It doesn't have a capacity for an item. So it doesn't know whether it wants an item or not. So it's going to pass that wants onto the activity. So we'll see that wants move to the activity. And then we'll see the activity decide whether or not it can take an item. So we'll see it say, yes, I need an item. That gets returned all the way back to the queue, and the queue says, okay, the path is clear, I can send an item. So this is one of the ways where you can, the messaging biases something in that you can combine blocks together in some kind of interesting ways. We can actually have the items wait in the queue for the activity, and this set block is kind of invisible. It's in between those two blocks, and it's not affecting the capacity of the queue. The item won't leave the queue until there's space in the activity. So now the queue says, well, you need to take an item, and when that set block gets the needs message, it will immediately respond with a taken, and then the item moves to the set block. Now it says, oh, my job is to set a property on the item, so I request a value from the block that I'm connected to. In that case, I'm getting the current time, and then that's returned to the set block, and we assign that to the attribute. Now, the set block can't hold items, so it immediately needs to send its items out. So notice there's no more wants message here. We're sending the needs message directly to the activity. The activity sends the taken message, and then that item moves on to the activity. Now the activity sends a message out its delay connector saying, oh, I need to delay my item for some amount of time. How long is that? It says, well, give me a value. That goes to the math block, and that propagates that message out to the two random number blocks, who each return the result of their random number. The math block sums them up and sends them back to the activity. So let's go back through that one more time. Sorry, I'm trying to go back. There we go. So you get the wants message to the queue. The queue says, I need an item. The create block tells the queue it needs to take the item. Then the queue says, okay, I've taken the item, and the item moves to the queue. Then we send the wants message from the queue to the set block. The set block says, I don't know if I can take an item or not, so I'm going to transfer that wants message onto the activity. The activity says, I can accept an item, so I need to take an item. And then the queue responds with the needs message. The queue sends the needs to the set block. There's a taken message from the set block, and the item moves into the set block where we get the value that we're assigning to the attribute. So now the item needs to move into the activity because remember the set block has no capacity, so it sends the needs message on down. The activity sends a taken back to the set block, and then the item moves to the activity. The activity then picks up its values for its delay time by summing the two random number blocks. So that's the basics of item messaging. There actually are some other incidental messages, a notify message that's in there as well, but I'm not going to go into that. That's only used in some specific circumstances. And there's also a pull mechanism, but that's really kind of the mirror image of this. There's a wants where the activity, once it completed processing, would try to pull a new item from the queue, and that would start with the wants message, and we'd get either rejects or needs back from that. So the pull is very much like the push, which we've seen here. It's just you flip it over, and that's just pulling an item through the model. So those were connector messages. Block-to-block messages are very similar, except that we send a message directly from one block to another kind of through the air without a connector. And the blocks that use this are the resource pool blocks, the throw and the catch blocks, clear statistics blocks, and there's some other blocks that communicate with this method as well. So, for example, you could write an equation that cleared all the blocks in your model. So if we didn't have a clear statistics block, you could write your own with this simple equation. So we check here to see if the simulation phase is 4. So we're only going to do this if the simulation model is running. And then for I equals 0, I is less than num blocks. This is a function that returns the number of blocks in the model. So num blocks right here. That gives us the number of blocks in the simulation model. So we're going to go through all the simulation model blocks in the simulation model, and then we send them a clear statistics message. If that block doesn't have a message handler for the clear statistics, then it just ignores it. If it does, then it will process and clear its own statistics. So you can use these messages yourself and use them in some kind of creative ways. So maybe you might have a list of blocks that you wanted to clear, and you could just call this or send a message to all the blocks that you wanted to clear on your list. Now, another kind of message is a database message, and this is a very powerful tool. What happens is if something in the database changes, we send a message to the blocks that are interested in that database. So blocks have to register themselves with the database table to get a notification of the change. Otherwise, there would be a real performance issue with that. If we send a message to all the blocks in the model every time something happened in a database, I'm sure you can imagine that would not be very efficient. So there's two kinds of database messages. One is the database structure. So say we add a new field or delete a field, add a new table, delete a table. Or the second type is data content changes. So that if a value in the database changes, then we'll get a message based on that. Now the data content change is one that you're much more likely to use in the course of the simulation. So the equation block and read blocks can react to a data content change. So you can set up these blocks so that if a value in the database changes, the equation will evaluate, or the read block will read that value and send a connector message out at that point. So this gives you a good tool for organizing your simulation models, so that you don't have to have connectors everywhere in the model. You can set things in the database and then have a read block that sends it to a plotter or somewhere else in the model that would be interesting in that value, or you can have an equation that evaluates when something changes. So I put together a simple model here. What I've got is the same model we had before: create, queue, set, activity, exit block. The set block, we're assigning an attribute to the time that the item starts service, and our activity delay is based on the sum of two random numbers. But I've added something else to the model. I've added down here a read block that's reading the queue length and the activity length, and I've linked those values to a database table. The database table is linked to the values in the blocks that are the queue length and the length of the number of items in the activity. And every time that those change, they'll send a message through the database to the read block, and then we'll plot those values out. Back a bit here. So by linking, what I mean is we right-click on the values. So in this case, this is the length of the queue, and we get the dialog that says, I'm going to create a dynamic link, and I've linked the queue length to a table that's called results, that's recording the queue length and the number of items in the activity, or the activity length. Then in the read block, I've selected this option that says when the data source changes, I'm going to read the data from the database. So every time there's a value that changes in the database, in that database table that read block is looking at, that read block is going to get a database message, a database content message. And the way the read block reacts to it is that it reads that value and it sends that value out its output connectors. So what we end up with is I've got a little animation that hopefully, oops. For some reason my animation isn't starting up here. I'll give it a moment. There we go. So even though there's no visible connection between the queue length and the number of items in the activity and this read block, it's still reading the values as they change in the database and sending them to the plotter. So this can be a good tool for organizing your models. If you want to, for example, have put some of your values, organize your data, or your results in the database, and then use an equation to calculate something based on those, this is a good way to do that. So another kind of message is dialog variable messages, and these are sent to a block when a dialog variable is clicked or changed. So for the most part, it's used by block programmers, but we do have some tools for you to access those. We've got a slider, a switch, and a buttons block that can be used to create your own message handler or work in your own model. So in this case, we've got a switch block that has a switch control in it, and you notice this dialog item name, which is switch_SWT. Whenever that's clicked, it's going to send a message to the code of the block, and it's got an output connector, so it'll send that message out that output connector. And it looks something like that. So we've got on switch, we call the set switch function, which processes whatever that switch is going to do. So I've put together a little model. I'm going to jump over to ExtendSim here and show you actually running. So this is our same model here. One change I've made is the activity now has the shutdown enabled. I've connected the shutdown to the switch block, and I've got a record message block that's recording the messages that go back and forth between the switch block and the activity shutdown connector. If I run this model, we'll start with our shutdown off, and we can see it running. If I click the switch, you can see I shut down the activity. So each time I'm clicking on that switch block, I'm sending a message that's starting out as a dialog variable message. The switch block itself processes that, turns it into a connector message that gets sent onto the activity block and actually shuts it down. So you can use these blocks, the buttons block, the switch block, the slider block, to create interactive interfaces to your model. So there's some messaging tricks, and I see that the display is slow to update again, so I'll give it a moment to catch up again. Hopefully it's updated. The stop message block can be used to block or stop a connector message. So if you want to have more control over the messaging, you can use the stop message block to do that. A pulse block, which you've seen in the earlier example, can be used to send out a periodic message. So you can send out messages every so often. The gate block can actually send out a message on every simulation event. This is called polling. In most cases, you don't need to do that in ExtendSim. Because of the nature of messages, you don't need to poll, but that's a simulation technique where you check or evaluate the system state at every event. The gate block is one way to do that. And we saw use of the record message block. This is a way you can view the connector messages at each step of the simulation. So this is very powerful for debugging. So you can see how the blocks are communicating with each other and the values that are communicated back and forth. You can view the item connector messages with the item messages block. So again, you'll see this wants, needs, notify, wants, needs, taken sequence with the item messages block. So that's what I had to talk about. I'll entertain any questions. I see there's a lot of questions on here, so let me look through. Many of them are not are about problems we had. And I apologize for the delays in the presentation. I'm not sure what was going on there. Usually this system works pretty well, but every once in a while we have some problems with that. Someone is asking, how is this different from Arena? We actually did an ExtendSim for Arena users webinar. I would encourage you to contact us, and I can get you a copy of that so you can see that. Or if you want to talk about that, I'd be happy to do that offline, but that's a little off topic here. We have someone asking about the new version of ExtendSim. We're a little ways off on that. The new version is going to be a big upgrade, so expect a lot of exciting new features there. We'll probably have a webinar on that later this year where you can see what that looks like. Someone else is asking about, Herman is asking about multiple core simulation, messaging between cores. That's actually a tricky problem because the messages are synchronous. When we send a message to a block, we have to wait for it to return. So we could divide the messages up among cores, but it would be a little bit like watching a tennis match. We'd send the message over to another core. It would process while the main core we're working on still would be processing, so or waiting for it. Let's see if there's any other questions here. Okay, that was kind of a quick session. I hope you found that helpful. We're going to provide us slides, and I'm going to edit this a little bit so we can a little bit of my talking about the problems we had, but we will have slides available.
Dave?
Yeah.
Scott Burry has a question about still gathering VOC, which I'm not sure of, for the new version. I'm not sure what VOC stands for.
No, and it says he's left, so we'll have to get back with him later. Oh, could we show a code example of messages between the blocks? Yeah, I did have a little bit of that. Let me back up to that example. Let's see where that is. Right here. So this is a code example of sending a message from one block to another block. And this could be in an equation block. This was actually pulled out of an equation block of one of our sample models. The other one, or it could be in the programmed block. And the function you're really worrying about here is send message to block. That sends a message directly to the block. I is the block number, and clear statistics message is the internal constant, which is the message handler. And there's a whole list of these documented in the manual. You, in fact, could send an open model message to a block if you wanted to, or an open dialog message if you wanted the block to execute whatever code it had in its on dialog message. I hope that answers your question.
He wants to see the code.
Oh, this is the code.
Oh, okay.
I can actually let's look at the clear statistics message handler. That might be useful too. So in our queue, I'm opening the structure of the queue here. We have a clear statistics message handler. This is pretty straightforward. All it's doing is resetting all the statistical accumulators to 0 or current time or whatever the initial value is. And it looks like we're seeing a blank screen, so we've got another delay here with our...
Dan Houston wants to know how in your read database example, how you sent the values from the queue to the database.
Oh, okay. I did go over that. Let me review it again. in the queue, if I right-click, I can do this with any parameter. I can link this to a database table. So I right-click on that, and say Create Edit Dynamic Link.
Okay, maybe hold up a second because we're
Yeah,
definitely
I'm
behind.
seeing everything is blank. Unfortunately, we've got performance issues. Well, I'll try to describe it. Select a dialog parameter, right-click on that dialog parameter, and say Create Edit Dynamic Link. And then you can link that to a database, a value in the database. And then every time the value of the dialog changes, that will change the value of the database, or vice versa. If you change something in the database, that'll change the dialog. So this is a nice way to create an interface or a link between what's going on in the dialog, the model, and the database. So I use this technique to link the parameters in the block to the database cells. And then I can read those database cells from the read block. Another way I could have done this is to use a write block and just written them out to the database with the write block. Either way is fine. It's a matter of preference.
Okay, it just showed up.
Looks like that came back again. So let me show that example one more time. So I right-click on the the dialog variable. I say Create Edit Dynamic Link, and then I've linked it in this case to the value field for the queue length record.
Karsten Herman has a question about the systematizing precedence of messages in a bigger model. Is there a problem with that?
The sequence of messages, sometimes it isn't necessarily a bigger model, but maybe a more complex model where you've got complex messaging going on. Sometimes that can be an issue. Often it refers to a condition that's a generic simulation issue called a race condition, or a time tie where you have multiple things happening at the same time and you need to control the sequence of those. There are some tools for doing that. One handy tool is to just filter everything through an equation block so that you have a message coming in the equation block and the values going out the equation block will go out in order, top to bottom. So that's how you can control how the messages are distributed throughout a simulation. You can also control it if you write your own blocks, or the equation block has actually a number of quite good tools for controlling how it reacts to messages and what messages reacts to programming, to those messages. Yeah, Karsten just pointed out race conditions happen in multi-core programming. Absolutely, that's one of the big issues with multi-core programming, and why that really in reality the simulation world has not been able to take advantage of multiple cores because of the race condition issue. Now I see a question, they want connector messages. Let's see if I can find an example of that. So this is the read block. So this is an example of the read block. This is post an ExtendSim, a message handler it's called. This is the last thing that's called before the simulation starts. So it's after an ExtendSim before the simulation is running. And we're just sending a message out to initialize all the values. So for the connector messages, we call a function called send message to inputs, and then or send message to outputs, and then which connector we're sending that to. So again, the connectors are pretty connector messages are pretty easy to use. We just say we're going to send the message and who we're sending that message to. There are, I believe there's some examples of message sending as well in our developer tips library that's included with ExtendSim.
And also in the developer reference.
Right, right. Any other questions? Well, I appreciate your time. I apologize for the lags that we've encountered today. We'll certainly be investigating that. You know, anytime you rely on technology, there's always a little bit of a risk that something won't work perfectly. If anyone has any questions, I'd encourage you to contact us after the session, and we'll be happy to answer them for you. This has been a brief overview of messaging. There's lots of interesting things going on behind the scenes here. I hope that you've learned something. I always do every time I put one of these together. It makes me think about this a little more critically. I do see one more question here. Oh, it's, yeah. If an activity block is requesting a large volume of items from a queue, such as 500 items, is there a way to speed up the items being pushed? Not really. They're getting pushed one at a time. We don't have a mechanism for moving a bulk number of items, but realize these messages are pretty fast. It sounds like a lot to do this wants, needs, taken sequence, but they move through pretty quickly. If you think about that as and the speed of modern computers, that really isn't a lot of work that's going on behind the scenes there. There are other things that take actually quite a bit longer, which would be updating dialog items when the utilization changes or something like that. It's actually slower than moving an item from one block to another one. So we're always working on these things to improve the performance of them. You could modify the activity in the queue block so that they moved a bunch of items at once, but I don't think that would really be worth the effort. I doubt you'd see much performance improvement for it, and it would be a little bit of work.
Dave?
Yeah.
One idea for that also would be to maybe use the workstation block.
That's true. The workstation block actually is a queue and an activity linked together, so that may be faster in your particular implementation. So if there's nothing else, I appreciate your time. And again, if there's questions, feel free to contact us. And we
Karsten wants the script.
Yeah, I don't have a predefined script, but we will be posting the PowerPoint slides and the recording of this. Okay, thank you very much. And the next session will be, oh, and one more question. Let's see. There will be source code available in future versions? Yeah, well, the source code is available now. If you have ExtendSim, you can actually get in and see all of the things I've shown you in terms of the source code. Oh, Scott Burry from Dow Chemical will be making the next presentation, so I hope that you all attend that. There's information about that on our website. Thank you very much, and I hope everyone has a good day.